Hi viewers, welcome to another video. In this video, I will be going to discuss all about current transformers, its working principle and why we use current transformer. Then I will explain the specifications of current transformer in very detail. So please don't skip any part of this video. So let us begin by discussing what is current transformer. Like all other transformers, the current transformer tends to transform the current from high level or high magnitude currents that flows in the primary to the equal proportion at low level in the secondary winding, which can be used with the measuring instruments or the protective devices like relays. The current transformer currents are expressed in primary to secondary current ratio such as 100 by 5 or 1000 by 5 ampere ratio. When we say 100 by 5 CT, it means that when 100 ampere flows in the primary conductor, the CT will produce 5 ampere. Similarly, for 1000 by 5 ampere. So this is the very important parameter of current transformer, which is the accuracy class. Each current transformer can have a metering class or the protection class. So what does it mean by metering class? Metering class means that the current transformer will be used with the metering instruments in order to measure the current at very high accuracy. Therefore, whenever the CT is intended to use with the metering instruments, they require good accuracy up to approximately 120% of the rated current. So in metering class, according to IEC standard, the accuracy classes are zero point 0.1, zero point 0.2, zero point 0.5, 1 and 3. So what does this class means? The class designation is an approximate measure of CT's accuracy. The ratio, which is primary to secondary current ratio, error of class 1 CT is 1% at rated current. It means that 1% of the total CT ratio will be the error when we are talking about class 1 CT. Similarly, when class is zero point 0.5, it means that there is a 0.5% error in the secondary current in proportion to the primary current. So the less the class, the more accurate will be the measuring CT. Now let's talk about protection class. The CTs are used with the protective relays in order to protect faulty circuits. It means that in this case, accuracy is not as important, but what we require that CT will be able to measure the accuracy current with high accuracy even if the primary current is many times of the rated current. So as you can see here, the class accuracy class for the protection is 5P20, 10P20, or it can be any figure something like this. What does it mean by 5P20? It means that the first number indicates the percentage error. So it means that there will be a 5% error in the secondary current with respect to the primary current. P stands for protection class and 20 means that 20 times of the rated current. So let me elaborate further. This figure 5 to 20 means that when 20 times of the rated current is flowing through the CT, the error in the secondary current may be plus minus 5%. As you all know that this much current can only flow in a circuit whenever there is a fault. Accuracy of metering and protection class is different. Now let's talk about another very important parameter, which is CT burden. So the burden is the total resistance in the CT metering circuit, and this includes the resistance of internal secondary winding of the CT, plus the resistance of the lead and also the resistance of instrument that is connected with the CT. According to IEC, the CT burden can be 1.5 VA, 3, 5, 10, up to 60 VA. It is to be noted that the CT burden is always represented by VA. Or according to NC or IEEE, the burdens are represented by B-1, B-2 up to B4. This means that a CT with a burden rating of B-0.2 can tolerate up to zero point 0.2 ohms of the impedance in the metering circuit before its output current is no longer a fixed ratio to the primary current. So here you can see that if the output terminals of the secondary winding is shorted with each other, then there will be no resistance and all the current can flow easily in a circuit and there will be zero VA burden since there will be no voltage across here. If for the same CT ratio 500 over 5, there is a zero point 0.5 ohm resistance that is seen by this CT. So it means that when 5 ampere flows, it will produce 2.5 volts, which is equivalent to 12.5 VA burden. So if you want to connect this CT on this load, you need a CT which has a burden of more than 12.5 VA in order to measure the current accurately. Similarly, if the resistance increases to 5 ohm, then the burden will increase to 125 VA and so on for all the combinations. So construction wise, there are two types of CT. First is like this, in which the cable is passing through the CT and it acts as a primary winding and the body of the CT acts as a secondary winding. And second is the bus type. The primary winding is a bus which is passing through a core. The one end of the cable is connected with this and the other on the other terminal of this bus. Again, this is the primary conductor and the body acts as the secondary conductor. So there are two types of CTs available. So this is the connection. This is the cable which acts as a primary conductor for which you want to measure the current. And obviously this cable is connected to some load. So whenever a current flows in this primary conductor, there will be a current generated in the secondary winding and the secondary winding will then be connected with any measuring instrument. So let's talk about the CTR or CT turns ratio. This is the equation for current and turns ratio. Primary current over secondary current is equal to the secondary turns over primary current turns. Let's say that we have 100 over 5 ratio CT. It means that a primary conductor will be considered as only one turn and the total current in the primary circuit is 100 ampere and the output of this CT is fixed, which is 5 ampere. So what will be the ratio? The ratio will be 20. So the secondary turns must be equal to 20 in order to produce this CTR. So what happens if we double the loop of this wire? For the same CT 100 oblique 5, when we double the cable inside the CT, it means that the number of turns of the primary has increased to 2, and if the number of turns of secondary remains the same, which are 20, it means that now the CTR is 10. Now what happens if the 50 ampere current flows in the primary conductor, the CT will output 5 ampere. So now for the same CT, you have reduced the CTR by increasing the number of primary conductor. This is again very important parameter, which is the polarity. Here the primary polarity is indicated by H1 according to IEEE or P1 according to IEC. Similarly, secondary polarity marks as S1 according to IEC or x1 according to IEEE. Again, the polarity of CT is dependent on the direction of the current that is flowing through the primary conductor. So let's say that the direction of the current is in this direction as shown by the red arrow. So if the current flows in this direction, then the direction of the secondary current will be just like this as indicated by the arrow. Similarly, if you reverse the polarity, the direction of the current produced by the secondary will also reverse. The secondary of current transformer should never be opened. And why is this so? It is because whenever the secondary is open, it means that secondary current will become zero, while there is still a primary current flowing in the primary circuit of the CT. So what happens in that case? No opposing MMF of secondary is generated, and the net MMF in the CT is all because of the primary current, which is very large, and this large MMF will produce large flux in the coil and will saturate the core because there will be no opposing MMF due to a zero secondary current. And what happens due to this large flux linkage? It will produce large voltage across the secondary terminal of the CT, which is very dangerous for the insulation life or for the humans. It is to be noted that the secondary of CT shall never be opened in any case. I hope you understand the basic concepts of current transformer. For more interesting videos, please don't forget to subscribe our channel. Thank you for watching.